Now let's take the next topic, which is reflection. What is reflection? The reflection of a point P in a line M is a point P dash such that line M is the perpendicular bisector of the line segment P dash as shown. Here, line M is called the mirror line or the axis of reflection, or also called the mediator. In other words, we can define reflection in the line M as the transformation which carries P to P dash, and this is denoted by M, that is the mirror image in the line M. Now, why do we need to study reflection? By reflection, we can know the image of a point in a given line. Now, how to find the reflection of a point? This can be done in three ways. We have reflection in the x-axis. Let us take a point P with coordinates as x, y. We want to reflect this in the x-axis. Let's first take a graph sheet to do this. We draw the x-axis and the y-axis. We mark any point P on the graph. Now we want to reflect this point P in the x-axis. So we will observe that the x-coordinate remains the same, whereas the sign of the y-coordinate will change. That is, we will have the reflected point P dash with coordinates as x, minus y. Now let's reflect the same point in the y-axis. We will have the x-coordinate sign changes to minus x and the y-coordinate remains the same. So we have reflection of the point P in the y-axis as P double dash with coordinates minus x and y. Now we reflect the same point P in the origin. We will observe that both the coordinates, the sign will change. That is, we have reflection of P in the origin as P triple dash with coordinates as minus x and minus y. Now before moving ahead, let's understand the concept of invariant points. Now a point is an invariant point with respect to a line if and only if it lies on the line. For example, we take a point on the x-axis. Then we reflect this point on the x-axis itself. So will the coordinates change? No, they will not change. So this point is called invariant in the x-axis. In other words, we can say invariant point is a point that remains unchanged under a transformation. Now we have some formulae over here which we've already seen. Let's revise them. If we have a point P with coordinates x and y, we reflect in the x-axis. We will get P dash x, minus y. Same point, reflect in the y-axis. We will get P double dash minus x, y. Same point, reflect in the origin. We will get P triple dash minus x, minus y. Now the prerequisites for this topic are: equation of the x-axis is y is equal to 0. Equation of the y-axis is x is equal to 0. Equation of a line which is parallel to the x-axis at a distance of a units from it is y is equal to a. And equation of a line parallel to the y-axis at a distance of b units from it is x is equal to b. Then we have if P with coordinates x1, y1 and Q with coordinates x2, y2 and a point M which is the midpoint of PQ, then M will have coordinates as x1 plus x2 upon 2 and y1 plus y2 upon 2. This is the midpoint formula. Now, keeping all this in mind, let's start with the problems based on this topic. We take the first one, which is quite simple. Write down the coordinates of the image of the point 3, minus 2 when reflected in the x-axis, reflected in the y-axis, reflected in the x-axis and then reflected in the y-axis, and also when reflected in the origin. Now we are given a point P with coordinates 3, minus 2. Now let's reflect this in the x-axis. When we reflect a point in the x-axis, the x-coordinate remains the same and the y-coordinate sign will change. So this point will become P dash 3, 2. Now we want to reflect P in the y-axis. So here x-coordinate sign will change whereas y-coordinate remains the same. So we get P double dash minus 3, minus 2. Now this point P, we want to first reflect in the x-axis and then in the y-axis. Now when we reflect P in the x-axis, we get 3, 2. And then we reflect this point in the y-axis, we will get minus 3, 2. Now in the fourth part, we want to reflect P in the origin. We get P triple dash minus 3, 2. The signs of both the coordinates will change. Now let's take the next problem. The point P minus 3, minus 2 on reflection in the x-axis is mapped as P dash. Then P dash on reflection in the origin is mapped as P double dash. Find the coordinates of P dash and P double dash. Now we are given the point P with coordinates minus 3, minus 2. Now we first reflect this in the x-axis. So the y-coordinate will change. We will get P dash as minus 3, 2. Now reflect this point in the origin. So the signs of both the coordinates will change. We will get P dash minus 3, 2 when reflected in the origin as P double dash 3, minus 2. So we have the required points P dash and P double dash. Now let's look at the next problem. Use a graph paper for this question. The points P and Q have coordinates 3, 1 and minus 2, 1 respectively. P and Q are invariant when reflected in the same line. Write down the equation of such a line. Also, find the image of Q when reflected in the origin. Let's draw this on the graph sheet. We draw the x-axis and the y-axis. Now we mark the point P with coordinates 3, 1 and also mark Q with coordinates minus 2, 1. Now we are told that P and Q are invariant when reflected in the same line. Now what do we mean by invariant points? That is, after reflection also, their value should remain unchanged. Now both these points are on the line y is equal to 1, that is a line parallel to the x-axis. So we need to reflect this in the line y is equal to 1, and still their value will remain the same. That is, P and Q will be invariant in the line y is equal to 1. Then we want to find the image of Q when reflected in the origin. Now Q has coordinates -2, 1. We reflect this in the origin, so the x and the y coordinate sign will change. We will get Q dash with coordinates as 2, -1. Now let's consider the next problem. State the coordinates of the image of each of the following points under the given transformation. Now we have the first point 3, 2, and it is reflected in the y-axis. When this point is reflected in the y-axis, its x-coordinate sign will change and the y-coordinate remains the same. So after reflection, we'll get the new point as -3, 2. Now we have the second point 4, -3. It is reflected in the origin. So the sign of both the coordinates will change. We get the point as -4, 3. Now the third point 2, 0. It is reflected in the line x is equal to 3. Here, in such a case, we must see what is the distance between the line and this point. The x-coordinate for the point is 2 and the equation of the line is x is equal to 3. So the difference between these two is 1 unit. So we must have the point, the reflected point, at a distance of 1 unit from the line but on the other side. So we will get the coordinate of the reflected point as 4, 0. Now we have the next point as 3, -4, and this point is reflected in the line y is equal to 2. Now we take the difference of the y coordinate with this line. We have -4 and here 2. Their difference is 6 units. So we need to take the reflected point at a distance of 6 units from the line y is equal to 2. So we will get the coordinates as 3, 8. Now we have a next problem as the point P 2, 6 is reflected to the following points. Draw the axis of reflection in each case and find its equation. We are given the points as Q 2, 2, R 2, -8 and S -6, 6. Now in this case, we are given a point P with the coordinates. We are told that this point P is reflected. To get these 3 new points, we want to draw the axis of reflection. Let's take the first part. P with coordinates 2, 6 is reflected to Q with coordinates 2, 2. Now we want to draw the axis of reflection. The x coordinate for both of them is the same, but the y coordinate is different. There is a difference of 4 units between these two coordinates, that is 6 minus 2, which is 4. Now divide this 4 by 2, half of 4, that is we get 2. So we must have the axis of reflection at a distance of 2 units from both these points. So we will get the line as y is equal to 4. Now let's take the second part in this. We have the point P with coordinates 2, 6. It is reflected to the point R with coordinates 2, -8. Again, the x coordinate is the same, but the y coordinates are different. Now take the difference. We have 6 minus of -8, that is 6 plus 8. There is a difference of 14 units between these 2 points. So take half of 14, that is 7. So the axis of reflection must be at a distance of 7 units from both these points. So we will get the required axis of reflection as y is equal to -1. Now let's take the third point. We have P with coordinates 2, 6. It is reflected to S with coordinates -6, 6. Here the x coordinates are different, but the y coordinates are the same. So the reflection is obviously along the y-axis side. Now we take the difference. The difference is of 8 units. Divide by 2, that is 4. So the axis of reflection must be at a distance of 4 units from both these points. So we get the required axis of reflection as x is equal to -2. Let's move on to the next problem. Use a graph paper for this question. The point 5, 3 was reflected in the origin to the image P dash. Write down the coordinates of P dash. If M is the foot of the perpendicular from P to the x-axis, find the coordinates of M. If N is the foot of the perpendicular from P dash to the x-axis, write down the coordinates of N. Name the figure PM P dash N. Find the area of this figure. Now in this case, we will obviously use the graph sheet. First take the graph sheet, draw the x-axis and the y-axis. We name the x-axis as x and the y-axis as y. We plot the point P with coordinates 5, 3. Now we want to reflect P in the origin to get P dash. So the coordinates of P dash will be -5, -3. Now we have P dash also. Now we are told to draw the perpendicular from P to the x-axis and name that as PM. We do that. We get the coordinates of the point M as 5, 0. Now we draw the perpendicular from P dash to the x-axis to meet at point N. We will get the coordinates of the point N as -5, 0. Now we join these 4 points. We get the required figure as a parallelogram because the opposite sides are equal and parallel. Now we are also asked to find the area of this figure. Now we know area of a parallelogram is base into height. Here we take the base as PM and the height as MN. So we will get the area as 3 into 10, that is 30 square units.